If you pick up a rock from the Kenyan desert, it usually looks like a garden stone. But if that rock comes from Lomekwi 3, it's actually a 3.3 million year old piece of technology. Now, this isn't some minor adjustment to the textbooks. The discovery of Lomekwi 3 basically extended the known history of human technology by about 25%. For decades, the consensus was that the genus Homo, our own direct ancestors, were the first to crack the basic physics of napping. We were wrong. These stones date back 3.3 million years, making them roughly 700,000 years older than the famous Oldowan tools. We're going to look at how a simple wrong turn in the Kenyan badlands revealed that our ancestors were far more capable than we gave them credit for. And we'll look at some monster rocks that are as large as a human head. Northern Kenya, near Lake Turkana. The landscape is essentially a moonscape of dust and heat. This is the Lomekwi 3 site, situated on the western shore of the lake, a region widely regarded as one of the most critical archives for understanding human evolution. The ground here isn't just dirt, it's the Lomekwi Formation. This specific geological arrangement of layers acts as a timeline of the Earth's crust, stretching from 4.5 million to 750,000 years ago. Standing here, you're in a million-year-old library of stone and ash. The wind across West Turkana strips away the youngest layers, exposing the rocks used by something that wasn't even human yet. It's a place where the Earth is slowly exhaling its secrets. Sonia Harmond and Jason Lewis took a wrong turn. It was a trivial mistake, but it led them to a patch of ground that rewrote the history of engineering. Beside them was Sammy Lokaroti, a local guide. Lokaroti spotted something in the dust. He didn't see a common stone. He saw an artifact. At Lomekwi 3, they uncovered an assemblage of approximately 150 published tools. This wasn't a random scattering of debris. The collection included anvils, cores, and flakes, found alongside 36 animal fossils. Then came the Technical Anomaly. The tools at Lomekwi 3 have a grain size significantly larger than any other rock in the surrounding deposits. This means no natural stones of that size exist in the local sequence. Someone had to carry them there. They weren't washed in by a river. They were selected and transported. Before the first stone tool, there were just plain rocks and unsharpened sticks used as clubs. Some early primates simply used naturally pointed sticks as primitive spears. Chimpanzees still do this. They break a branch and bite the tip to sharpen it. That's intuitive behavior. However, the Lomekwi 3 tools represent a cognitive shift. These were not found objects, but cores, rocks that had flakes deliberately removed. The large stone hunks bore marks showing they had been fractured with intent. This wasn't random battering. It was a technique. The maker struck a platform on the rock repeatedly in the same direction to remove flakes in a uniform way. Some pieces show evidence of being struck 10 to 15 times in the same direction. This is the first documented instance of purposeful manipulation of a rock's geometry to create an edge. It's essentially a machine, where another rock serves as the hammer. The evidence is written in the scars. At Lomekwi 3, you don't just find the finished tool, you find the trash. There are cores, the parent rocks from which the edges were carved, and the usable flakes that served as knives. But the real proof of napping is in the debitage, the tiny, razor-sharp shards of rock that fly off during the process. Because these shards were found in situ, it means the tools weren't moved by a river or shifted by millions of years of geology. They were manufactured right there on the spot. It's a technical jigsaw puzzle. When researchers found a flake and its original core, and they were able to refit them, clicking the rock back into place, this proves a mind was intentionally subtracting material to create a sharp edge, rather than rocks simply colliding in a riverbed. Now we hit a timeline problem. The earliest fossil attributed to the genus Homo is approximately 2.8 million years old. That leaves a gap of 500,000 years between the first member of our own genus and the tools at Lomekwi 3. In a field where we usually define humans by their ability to make tools, these rocks have just changed the job description. So, who was actually holding the hammer? We have to look at the neighbors. Australopithecus afarensis, including the famous Lucy, dates to 3.2 million years ago. They were present. But even closer are the Kenyanthropus platyops fossils, found about 5 kilometers from Lomekwi 3 and dating to 3.5 million years ago. We're looking at a scenario where technology existed long before the handyman ever arrived. The spark of engineering didn't belong to the genus Homo. It belonged to someone else. These early engineers didn't just stumble upon the right rocks. They made very specific, calculated choices. For instance, the hominins at Lomekwi 3 transported large natural stones weighing 10 to 20 kilograms, carrying them up to 100 meters. To put that in perspective, imagine a creature about 1.2 meters tall hauling a 15-kilogram anvil across a scrubland. This wasn't a random walk. They specifically selected basalt for the anvils because of its density, which provided the necessary counterforce when striking a tool. To make this work, you need 2 hands, one to hold the hammerstone and one to stabilize the core against the anvil. But basalt was only half the equation. For the actual blades, they preferred phonolite, a volcanic rock with superior flaking properties. These fine-grained volcanic cobbles were easier to work with and produced a much sharper edge. This wasn't a one-off experiment. Phonolite was used consistently in the West Turkana region for over 1 million years, a preference that lasted all the way into the Acheulean period. The timeline continues to shift. We then have the Oldowan tools, dating between 3 and 2.6 million years ago. These weren't just scattered pieces of rock. They were found alongside a hippo and a molar belonging to Paranthropus. It's a strange, quiet image. A single tooth uprooted from the earth alongside these tools, and a creature like Paranthropus, perhaps using a stone flake to process a hippo carcass. The cognitive load here is subtle but real. It isn't just about hitting rocks. It's the coordination of a tool, the remains of an animal, and a non-human hominin species. The evidence is just there, in the dirt, in a silent report of an afternoon 3 million years ago. Oldowan tools, marking the formal beginning of the Stone Age, approximately 2.6 million years ago, shifted the focus from raw power to precision. These choppers and scrapers were created by chipping a few flakes off a rock to transform a pebble into a knife. Between 2.6 and 2.3 million years ago, this required a sophisticated understanding of geometry and fracture mechanics. They were essentially the Swiss Army knives of the Pleistocene, used for butchery, crafting, and processing hides. Then came the Acheulean tool. Dating back to approximately 1.8 million years ago, these were the teardrop-shaped hand axes found across Africa, Europe, and Asia. Homo erectus and Homo heidelbergensis used these bifacial tools because they were thinner and more effective. The leap in cognitive load was massive. To produce a single Acheulean hand axe, a maker had to remove 60 to 150 flakes, visualizing a symmetrical final form before the first strike. In sites like Boxgrove, England, the axes are perfectly symmetrical. It was no longer just about a sharp edge, it was about intentional design. It's slightly ironic. For decades, the scientific community clung to the label of Homo habilis, the handyman, as the sole inventor of technology. Lomekwi 3 completely dismantles that definition. The knack for crafting didn't start with us. It turns out the Australopithecines or their cousins were using tools long before the genus Homo arrived to take the credit. Of course, the archaeological record is inherently biased. We only find the things that don't rot. Stone Age tools were made from stone, wood, and bone, using minerals like quartzite, quartzite, chert, basalt, flint, and rhyolite. Wood and bone vanish over millions of years. This means the Lomekwian tools are the only surviving evidence of a cognitive leap that likely happened much earlier. The entire era of lithic technology lasted until about 5,000 years ago with the emergence of metallurgy. The truth is, we're essentially looking at a gap in the history of our ancestors' intelligence, filled only by the remaining shards of volcanic rock. We're left with the image of a small, bipedal creature, barely 4 feet tall, standing in the heat of the Turkana Basin. This creature wasn't a human by our definition, but it possessed a specific technical ambition. It didn't just use a rock. It imagined a shape inside that rock and used a second stone to force that shape into existence. It carried a 15-kilogram basalt anvil across 100 meters of scrubland, not because it was a game, but because it understood the physics of counterforce. This realization that the spark of technology didn't belong to the genus Homo, but to an earlier, forgotten experiment in intelligence, changes everything. We aren't the sole inventors of the tool. We're simply the latest version of a 3.3 million-year-old habit. The evidence remains in the dirt, a few shards of phonolite, and a scar on a rock that refused to disappear.